For 72 seconds, humanity received a deliberate broadcast from deep space. And then, the universe completely went silent. In 1977, a telescope received a signal so powerful, scientists wrote "Wow" right on the page. For 50 years, the official story was that it was never repeated. But a new calculation reveals that we have been completely looking in a wrong direction. Let's decode the mystery behind "Wow" signal. It's August 15, 1977. It was around 11 pm. You are in a field outside Delaware, Ohio, a small town of about 15,000 people, surrounded by corn farms. Nothing about this place suggests that anything important has ever happened. But sitting in that field is one of the most unusual machines in the world. It's called Big Ear, and it's a radio telescope, the size of 3 football fields. It contains 2 enormous flat metal reflectors, each over 300 feet long, tilted towards the sky. It was the largest telescope of its kind in Ohio, and since 1973, it had been running the longest dedicated search for extraterrestrial intelligence in human history. The way Big Ear works is simple but clever. It can't swivel left or right to track a specific star the way this telescope can, and lets the rotation of the Earth do the work. As the planet slowly turns, the telescope's beam sweeps across a narrow strip of sky. After a few days in one position, it adjusts slightly and sweeps the next strip, inch by inch, night after night. It scans the entire sky over and over, looking for anything unusual. The data it collects comes out on a long strip of printed paper. An IBM computer processes the signals and prints a single character for every 12-second window. At every frequency it's monitoring. High numbers and letters mean a strong signal. Low numbers mean background noise. A volunteer comes in every few days, picks up the stack of printouts, sits at a desk and goes through them one by one. It's very slow and careful work. Most of the time the printout is just columns of ones and twos, the constant background hum of the universe. You could spend weeks going through this data and find nothing worth stopping for. Most volunteers did exactly that, for months at a time, without ever seeing anything unusual. Tonight, the data looks the same as every other night, until at exactly 11:16 pm. The telescope's beam drifts across a small patch of sky in the constellation Sagittarius, and something is broadcasting there. The computer scale works like this. Numbers 1 through 9 represent low signal strengths, and when a signal gets too strong for a single digit, the printer switches to letters. Letter A equals 10, B equals 11, and so on up the alphabet. The sequence that prints in that one column at that one moment is 6EQUJ5. The peak letter is U, which corresponds to intensity level 30. That means the signal was 30 times stronger than the background noise of deep space. And it didn't just spike randomly. It rose smoothly, climbed to that peak, then fell smoothly back to nothing, over exactly 72 seconds. That shape matters a lot. A satellite passing overhead would create a much faster, messier reading. Satellites move too quickly across the beam. An aircraft would produce something erratic and inconsistent. Random interference or equipment malfunction would cause an irregular spike, not a clean, controlled arc. The smooth rise and fall over 72 seconds is the exact pattern you would expect from a signal coming from a fixed point in space. Something stationary out there, just sitting and broadcasting while the Earth's rotation slowly carried the telescope's beam past it. Nobody saw it in real time. The data printed got stacked in a pile with hundreds of other pages and sat there for several days before anyone looked at it. A few days later, a man named Jerry Iman sat down at his desk with that stack of printouts. Iman was 47 years old, a former professor at Ohio State, and he worked on this project as an unpaid volunteer. He believed sincerely that if intelligent life existed elsewhere in the universe, this was how we would eventually find it, by listening carefully, patiently, over many years. He had been doing this for 4 years without finding anything that couldn't be explained. He went through the August 15th printout the same way he went through every other printouts, column by column, page by page, scanning for anything that looked abnormal. And then he found it. He stared at the sequence for a long moment. He checked the column header to make sure he was reading the right channel. Then he checked the timestamp, he checked the frequency, everything. Everything confirmed what he was seeing. He had spent 4 years learning to recognize what background noise looks like. He knew what a satellite blip looks like. what interference looks like, and what equipment errors look like. This didn't match any of those things. He picked up a red ballpoint pen, circled the sequence carefully, and wrote one word in the margin next to it. Wow, that's the entire origin of the name. One man alone at his desk on an ordinary morning, seeing something that took his breath away, and writing down the first word that came to mind. That signal annotation in red ink on a strip of green and white paper became the most famous note in the history of the search for extraterrestrial life. Iman later said that he didn't want to jump to conclusions. After writing the word, he deliberately kept going through the rest of the printout, looking for anything else unusual, trying to keep himself calm and rational. There was nothing else unusual in the entire printout, just that one column from that one night. When Iman showed the data to the team, the reaction was immediate. They went through every possible explanation. They checked the signal against all known satellites. There was no match. They checked aircraft activity for that night. There was nothing matching. They also looked at whether a military transmission could have created it. But the 1420 MHz frequency was internationally protected for radio astronomy research, and it was illegal for anyone to broadcast in that frequency. They pointed Big Ear back at the exact same coordinates in Sagittarius that same night. The signal was gone. They came back the following night and the night after that and heard nothing. Over the following few weeks, they dedicated the telescope entirely to that one patch of sky, listening every night and getting nothing back. Then other telescopes joined the search. The very large array in New Mexico, 27 radio dishes working together. One of the most powerful listening systems ever built was pointed at the same coordinates. Facilities in Europe, Japan, and Australia joined in. For months, they listened, and then for years, and eventually for decades. Teams of scientists kept returning to those same coordinates in Sagittarius across nearly half a century of searching, each time hoping that whatever had broadcast on August 15th would broadcast again. It never did. As of today, 47 years later, not a single follow-up observation has detected their signal again. Scientists went through every natural explanation. A pulsar was ruled out. Pulsars repeat their signals with clockwork precision and don't just go silent after one burst. A quasar was ruled out. In 2017, a researcher named Antonio Paris proposed that the signal came from hydrogen cloud surrounding a comet passing through that region of sky. The original Big Ear research team rejected the idea. The comet he identified was not in the correct position in 1977. And comets simply don't produce signals intense enough, which is 30 times more to the background noise. In 2024, a team at Arecibo Observatory suggested that the signal might have been a cold hydrogen cloud, briefly energized by stellar emissions, a rare natural event. Even that explanation remains unconfirmed. After nearly 5 decades of investigation, the source of the WOW signal has never been officially identified. Jerry Iman died in 2025, still without an answer. The red ink on that printout is still visible. Now, I need to take you back 18 years before that signal ever arrived to a completely different story in a completely different place that has nothing to do with Ohio or radio telescopes and has nothing to do with Jerry Iman. It's 1959, Cornell University in New York. Two physicists are sitting in an office. Their names are Giuseppe Cocconi and Philip Morrison. Cocconi was an Italian physicist who had survived World War II and came to America to work alongside some of the greatest scientific minds of the century. Morrison had worked on the Manhattan Project. He was one of the physicists who helped to build the atomic bomb. These were very experienced guys, and they were trying to solve a problem that nobody had ever approached scientifically before. If intelligent life exists somewhere in the universe, and if they want to contact us, how would they actually do it? Think about the scale of the problem. The distances between stars are so vast that even traveling at the speed of light, a journey to the nearest star system would take over 4 years. Sending a physical object is essentially impossible with any technology we can imagine. But electromagnetic waves, radio waves, travel at speed of light. They can cross the distance between stars in years rather than millennia. They can carry any information, and they cost almost nothing to produce compared to the energy needed to send a physical object. So radio makes sense as a communication method, but there's a catch that Cocconi and Morrison were trying to solve. Radio has billions of possible frequencies. If a civilization somewhere in space wants to send a signal toward Earth, which frequency do they transmit on? They have no way of knowing which frequencies we are monitoring, and we have no way of knowing which frequency they would choose. Without some kind of pre-agreed meeting point, the chances of getting signal from another civilization is nearly zero. There has to be logical frequency, one that any civilization would independently arrive at, without needing to coordinate with anyone. This was the project Cocconi and Morrison were working on. And finally, Cocconi and Morrison figured out what that frequency was. Hydrogen. Yes, hydrogen is the most abundant element in the universe by a massive margin. About 75% of all normal matter in existence is hydrogen. It is found everywhere, in stars, in gas clouds between stars, in the vast empty space between galaxies. Any civilization that has ever looked at the universe with a radio telescope has detected hydrogen. It is one of the first things you discover when you start doing radio astronomy, regardless of what planet you are on and what technology you have developed. And hydrogen has a very specific physical property. When an hydrogen atom's electron flips its spin state, it releases energy in form of a radio wave at exactly one frequency. It is 1420 MHz. Not approximately, not roughly, exactly. It is a constant of physics that doesn't change depending on where in the universe you are. Every civilization that has ever studied the sky would eventually discover this frequency and recognize it special. The one frequency that any civilization would independently arrive at when thinking about interstellar communication, without needing any prior agreement. If you and a stranger need to find each other in a city you have never visited, with no way to communicate in advance, you both head for the most recognizable landmark, the main train station, the central square, whatever the obvious meeting point is. You don't need to discuss it because it's the only logical choice. For intelligent civilizations across the universe, 1420 MHz was that meeting point. They wrote this theory in a 2-page paper and submitted it to the Nature, the most widely read and respected scientific journal in the world. It was published on September 19, 1959, under the title Searching for Interstellar Communications. Here's something important to understand about what it meant for this paper to be published in 1959. Searching for extraterrestrial intelligence was not considered a respectable scientific pursuit at that time. It was the kind of topic that could damage your reputation and could damage your career. Frank Drake, a young astronomer at Green Bank, West Virginia, had been secretly developing his own plan to do exactly this kind of search, but he was keeping it completely private because he was afraid of how his colleagues would react. When Cocconi and Morrison published in Nature, Drake felt safe enough to go public with his work. In April 1960, less than 6 months after the paper came out, he pointed an 85-foot radio telescope at two nearby sun-like stars called Tau Ceti and Epsilon Eridani. He tuned the telescope exactly at 1420 MHz and it started listening. He named the project Ozma. Drake listened for 4 months, 6 hours a day. He heard nothing meaningful, but the experiment had a bigger impact than results. It proved that this kind of search was scientifically feasible, and it inspired other astronomers to start their own programs. Over the next decade and a half, SETI programs launched across the United States, the Soviet Union, and Europe. Some lasted months, some lasted years. In 1973, Ohio State University converted Big Ear into a full-time SETI observatory, the program that would become a longest running search of its kind in history. Here is what nobody has actually calculated. In 1959, two scientists published a paper in the world's most widely read science journal, clearly announcing that Earth would be listening for signals at this frequency. That paper was read by physicists and astronomers around the world. It was cited in other papers, discussed at conferences, and taught in university courses. But a scientific paper isn't the only thing that leaves Earth. Since 1906, when humanity first started broadcasting radio signals, those signals have been leaking into space in every direction. Television broadcasts, AM radio, military radar, all of it traveling outward at the speed of light, spreading through space in an ever-expanding sphere. By the time this paper was published, Earth's radio signals had already been traveling through space for 53 years. That means the sphere of our broadcast had expanded 53 light years in every direction, like 53 light years of cloud covering the Earth in every direction. Any civilization within 53 light years of Earth in 1959 could theoretically have been picking up our radio signals for decades. They would have heard our earliest experimental broadcasts, our World War II transmissions, the beginnings of television, decades of proof that something technologically active was happening on this planet. And then in 1959, something new arrives in the stream of signals. Not random noise, a structured, precise mathematical announcement. Understand this. This scientific journal paper was read in a television broadcast. It was an announcement. This is where we are listening. This is where to reach us. Now imagine you are a civilization that has been passively monitoring Earth for decades, because it has already been more than 50 years since radio waves started traveling through space. So some extraterrestrials could have already been monitoring our signals, but they couldn't have understood those signals. And then clearly Earth tells you which frequency they are monitoring. Then what would you do? They understand the frequency, they build a transmitter, point it at Earth, and transmit at 1420 MHz, the exact frequency that paper specified. But the WAV signal's exact position in the sky has never been pinned down precisely, because the Big Ear telescope used two receiver horns, and scientists have never been able to determine which one detected the signal, and the uncertainty window between them is large enough to contain several nearby star systems. Nobody has systematically checked whether the signal could have come from one of these systems. Nobody has run the specific calculation publicly before. I want to be honest with you. This is a theory built from verified facts, and it is not published anywhere or officially examined. It hasn't been proved right, but also it hasn't been proved wrong. The signal have every characteristic that extraterrestrial signal would have. Narrow band, correct frequency, correct intensity pattern, correct duration. It lasts exactly as long as the telescope's beam could hold it. And then it goes completely silent, never repeating, which is exactly the behavior you would expect from a civilization sending a single test transmission to see if anyone was home. If they wanted to check whether a planet was listening, they wouldn't send a continuous signal. They send one clean transmission at the frequency we announced, and they wait for the reply. But Earth never replied. By the time Iman created that printout and the team started making phone calls, the window to respond had already been closed. If something sent that signal, it has been waiting for a reply for 47 years and has heard nothing from us. The original printout sits in a museum of Ohio today. You could walk past it without knowing what it was. Big Ear itself was demolished in 1998. This theory may not be true, but in these 50 years, nobody has come up with a better answer.